Okay, well, welcome. This is our first Sunday after kickoff. So, kickoff was yesterday, and now we have a new game called Rebuilt. And we are going over strategy and some ideas about what to do in this game. Um, we'll get deeper into a little bit of a CAD design, but I want everyone to really kind of keep the big picture on what the rules are, make sure we didn't miss anything that's, like a rule about height restriction. If you're saying that we should make the robot really, this certain height so we can climb easier, but then the rules specifically say you can only be this high, we need to like flag that conversation and make sure everyone knows what the rule is. So don't be shy if you feel like we're talking about something and we just didn't understand the rule, or maybe you don't understand it. I posted the links to the rules. Make sure you go read them because it'll help channel our strategy to make sure we're not violating any rules. Otherwise, we could be wasting a lot of time down the wrong path. But in general, I want you guys to read the rules. I want you to watch the game reveal a few times. I want you to go look at the field videos, all that kind of stuff. So don't feel like you're going to just immediately get everything. I have to go back and watch all these things carefully too. But that's just kind of how the start of this season goes to understand how this works. No one's played this game before. The rules are probably not even exactly right. They'll post updates every week about the rules. So there's already been some discussion online about issues with the rules, and there's possibly some problems with those rules that will get fixed pretty quickly. They post them every Tuesday, so we'll find out what the changes are. But to kick things off, we'll let Cedric start with some ideas that he's going. He'll do a screen share.
Yeah. Okay. Do you guys see my screen?
Yes.
Do you guys see my on shape?
Yeah.
So a big part of the discussion ever since yesterday has been we knew we wanted to ground intake because we felt like it was very vital to being competitive is being able to intake from the big piles on the ground and not just from the human load. So the big discussion has really been, do we want to go through our bumper or do we want to go over the bumper? There's lots of disadvantages and advantages to each one. On the side of through the bumper, which is, like as it sounds, through the bumper, advantages include nothing extends out of the robot, so you can't really get hit. Your intake can't get hit, or there's a lot more that has to happen for your intake to get hit. It's integrated. There's a lot of things to think about, but if something breaks on it, like we experienced in Crescendo, intake and an intake that's integrated into the drivetrain can be real tough to really maintain and work on. Or we could go with something over the bumper, whether that be pivot or a 4-bar, and allow us to really, it's much more common. It's been done a lot more. And it'll be easier to repair, but obviously there's that extra motion of having to deploy it and it's vulnerable. I have erred on the side of caution. We have worked with under/through the bumper stuff in Crescendo, and it wasn't great. We had lots of trouble, especially with maintenance and keeping it in good shape. And so I'm on the side of I rather do an over the bumper intake because of those reasons. So what I developed since yesterday was trying to create a 4-bar because I think a 4-bar is a decent compromise between like a pivoting over the bumper intake and a through bumper, because it still does the job. And then it's the nice thing about a 4-bar is if it takes a head-on collision from here, the 4-bar would be able to, if we build it right, it would be able to collapse on itself instead of just taking all the energy and shattering. And if we make it out of polycarb, if it gets hit from the side, it should just be able to flex. It'll just wiggle a little bit and go back into place. And then the nice thing about this intake specifically, what I tried to do is attempted an uneven 4-bar. which means both of the linkages here are not parallel and are not the same size. So you can get a little bit more of a complex motion. With the key kind of idea being like, I want to still be able to get the 4-bar action, but be able to stow when the intake is stowed, have it stow relatively compact, because we noticed this year the robot perimeter got reduced a little bit, and that's going to affect, it's going to force us to have to package our mechanisms a lot tighter, and that usually leads to complications. So what I made was a 4-bar like this that would be in the stow position here, and then would deploy. I tried to look at the first one that I really looked at good was the Citrus Circuits in 2022. They had a similar system, but it was different in that they used a 10-inch ball, or 9.5, 10-inch ball, and that allowed them to basically, they didn't have to bring their intake down from their robot height. They kind of just flipped it outward. So I also looked at Team 254, the Cheesy Poofs, in 2017 or in 2021, where they had yellow dodgeballs. They also have this sort of uneven 4-bar, but unfortunately they don't have a CAD release from what I've seen. So I haven't been able to look at it super closely, but it's the same sort of idea. Stow really compact, but still be able to intake balls efficiently. And so earlier this morning, I added a lot of other stuff about like the things I think we should have. We discussed, obviously we want to shoot, and we kind of discussed an adjustable shooter, because we thought that if we didn't have one and we were restricted to one location, a bot that may be playing defense would be really effective at defending us if we can't shoot from more than one spot at least. So we would have a variable hood with a flywheel, and then we also agreed that we wanted a climb. Now we said maybe a level 2, but the more I thought about it, and after watching the Cranberry Alarm RI3D, they made a good point to where there isn't really a point to restricting yourself to level 2, because all the rungs are 18 inches apart. So floor to 1, 1 to 2, 2 to 3, they're all 18 inches apart. So let's say you have a level 1 climb and then you have a level 2 climb. Going from level 1 to level 2, going from level 1 to level 2 is going to be about the same as 2 to 3, because of the same 18-inch gap between the levels. So it's definitely something we need to consider. I had a really, and then I took this kind of block CAD and then put it into the field just so we have an idea of what it looks like. So you see here, this purple would be some sort of hopper or funnel that we would store all of the fuel in. And so you can see on the field here, there's some stuff with the Crayon CAD software that doesn't allow me to customize certain things. So like the telescoping tubes, we would have to just, find our dimensions that we need. And yeah, we would still be able to drive under the trench, which we also discussed was critical. And then you can see here the intake that I made in its stowed position, it's still able to stay under the trench by I measured it, it was like 21.5. So it's under by like 3/4 of an inch. So yeah, it should be a good amount under. And then I've also seen a lot of discussion on how much fuel a robot should have. I've seen teams say like 30 to 40, and then I also saw like a team like Cranberry Alarm who's doing the RI3D. They are aiming for like 50 in their thing, and they're aiming to shoot at a rate of like 10 balls a second. And so they are doing this sort of design, which might work, where the funnel extends after the match starts, which allows for which allows you to hold more fuel, and then they have a shooter at the end of it. So yeah, that's what I've been kind of working on. Most of the time was spent on the intake, because I had to figure out how the linkages kind of relate to each other and figure out how they work. And so, yeah. And then this morning I added this clearance zone just to see how many we can fit. Right now, this is 18 by 18 by 12. And a range, it's able to hold 12 fuel. But as you can see, there's some space out by the end of the robot, on the edges of the robot. And so we would hypothetically be able to still fit more. And this is also a 27 by 27, just because that's what we have at Westside right now. And so that's what I'm thinking. Like, if I'm going to prototype this, it's going to have to be on that drivetrain. But we also discussed yesterday that in order for us to climb easily, we thought it was important to be long and skinny. We thought that it would be important to be long and skinny because it'll allow, because due to like the shorter nature of the climbing structure, a wide robot may not necessarily, a wide robot would be tough to climb with because of just how little space there is to climb. So we discussed kind of a longer and skinnier design, which would help us climb with a smaller profile. Yeah. That's what I've been working on. We've also been going back and forth about obviously the over versus through discussion. I personally just think over is better due to maintenance is the one key thing that I'm really concerned about. Also in this game, there isn't really any protected zone throughout the match. The only protected zone is the last 30 seconds. This area is protected for climb. So with that being said, there might be a lot of like robot to robot collision at pretty high speeds, and yeah, just a lot of really rough defense. And if we were to do a through bumper intake, I think from what I've seen, what we would have to do is make kind of a cutout in our front drive rail, which would weaken the integrity of our whole drivetrain. And I don't think that's a worth it trade-off, because sure, you'll have an intake that's protected, but then your drivetrain's vulnerable to warping and bending, and that's an arguably larger issue to have. It's also just in terms of effectiveness, a deployable intake like this, I made it kind of slim in this prototype, but we could hypothetically bring it all the way out to the edges and make a full width intake. And doing this allows us to have a fairly large acquisition zone compared to a through bumper design, where if it's integrated between our swerve modules, we would have to physically drive into the ball, and it would make our acquisition zone pretty small. So I'm pretty strongly I like the idea of having an over bumper versus a through bumper intake currently. Yeah, that's what I've been working on for the past day.
In terms of a wide intake, it is going to be pretty valuable. And and if we were going to change our geometry out of square, let's say we were a rectangle, obviously we'd want to have our wide side be the intake side.
Yeah.
And if that becomes the case, it might make sense to put the climber on the narrow side.
Yeah, the whole idea is if we were a skinnier robot, the skinny side would face this climbing structure, basically, so that we have that extra space for a teammate or two teammates to climb on this side.
Makes sense.
Yeah.
What are your thoughts on turrets?
I don't know. I just think I know IndyMark this year, they sell a turret in a box, which a couple of, I think Cranberry Alarm is working on a turret with that system. But I think it's just too big of a leap into the unknown. I mean, I've never personally built, and our team has never really built a turret before. And turrets can get real complicated real quick. And so, and especially with a swerve drive, in the age of swerve drive, I don't see enough of an advantage to try a complicated system like a turret, where compared to like we can just change the swerve heading and move however we need to move to get to where we need to shoot. So although yes, I guess a turret would make the robot more competitive, I just don't see the trade-off between like added complexity and more risk compared to its competitiveness.
Yeah, I think it might be a stretch for our resources this year. We have, it's been a while since we built a shooting tilted hood, and I can't say that we're really proficient at doing that. So that alone might be more of a challenge to us. And once you add a turret, you've now added another degree of freedom that
Yeah.
you have to compensate for. And if, let's say, the turret is not very accurate and it gets off a few, degrees, then our shots are all terrible. We might
Yeah.
be just missing a lot of our shots purely because we don't have our turret tuned correctly. So it could be a major challenge for us as a team.
Mhm.
I like all the process. Does anyone have other like comments or concerns with kind of the general design ideas?
For the traversing around along the field, are you gonna try and go over the bump, or are you gonna try and go in under the?
Yeah. So we said at Lamar during kickoff that we personally thought, just by looking at the game before any of the before, just right after kickoff, we decided that like we wanted to be able to go under the trench because we thought this going over the bump was too risky in terms of getting beached. But I've seen a lot of RR3D teams, and even with a swerve with 1 inch bumper clearance, they're able to clear this as long as they hit it with, as long as they don't approach it at a turtle's pace. Um, I think the only concern about the bump is if you approach it too slow, you get in a position where two of your wheels are on it and two of your wheels are hanging off, and you only and the wheels, they don't have enough traction against the slippery plastic to move the robot any further. But other than that, I think we should still push a design that allows us to go under the trench to prevent any sort of bottlenecking caused by defense. But at the same time, I think even if we do that, I think we'll still be able to drive over the bump with relative ease if we have to.
I'd be careful with because you're saying you want to be long and thin, and
Yeah.
like the longer your robot is, the more you'll get beached.
Yeah, that's true.
Right. So you gotta think about that. Also, another option you can do for going over the bump is going at it at like a
Diagonal.
45 degrees. Yeah. That's something like we do on
With the cart at
the cart,
competition.
right? Yeah. So it's the exact same principle. So could be a good idea.
Yeah, I think if we did do the long, we would only go the wide side up or a diagonal or something. We would just not
Yeah.
go long.
Yeah.
Because you could run
It's just
risk.
purely practice, I think. Yeah. It's one of the things where it's like if you do it, you only have to do it one time in a match. If it happens, you're stuck.
Yeah.
Yeah, here's a real conundrum though. If we decided that we're really comfortable with going over, should we really limit our design to be under the trench if we feel really comfortable going over the ramp?
Good point.
Yeah. It's also a matter
because
of
your
like,
hopper gets much bigger, right? You can fit a lot more. You can do more with your climber. You really open up your design.
I mean, it's the difference is basically like a little less than 8 inches, because the max height is 30, and this is 22 and 1/4, I think 22.25. So it's a relatively sizable difference considering our drivetrain in general has to be somewhat compact for a long and thin robot. So yeah, very true.
I think not being able to hit 30 will be like it'll let you skip like your first like intermediate the stage for the first climb for like the first rail because you need to
That's true.
first go up and then do the 18, right? But if you can skip that whole, if you can you have 30 inches, you can make you get like 12 inches of height instead of 4.
Yeah.
So it's a lot easier. Yeah, yeah, something to think about. Did you guys talk about the new bumper rules and stuff at Lamar?
Well, a little bit. So the new bumper rules this year are, yeah, they're a lot more, I would say, relaxed as it was opposed to last year. You could do bumper cutouts, which is what we would have to do for a through bumper intake. Based on what I read in the rules, each side of your robot's perimeter only need 5 inches worth of a bumper covering. So in theory, a team could go back to doing the 4 corners like a lot of teams used to do. I personally think that we should still just do bumpers all the way around, because again, due to that, keeping our drivetrain and our robot safe. I've heard from mentors and other just reading online on Chief Delphi that corner bumpers a lot of times lead to bent drivetrains, which was it's just not a great thing.
Another thing to think about is the hollow pool needles we usually use are no longer legal.
Yeah.
So yeah, I don't know if I don't know what the plan is for bumpers, but just make sure you guys know that.
Yeah.
Really interesting. I didn't even read that part yet.
Yeah, it needs to be solid, or you can need to use like a
solid core pool noodle would work, but
solid core pool noodle will be okay. They also say like you can use like the Vex tiles.
Yeah, I think we've been using solid core pool noodles for a little bit now. I don't think we use the hollow core.
Well, yeah, last year we definitely used solid.
Okay.
Yeah.
Just making sure. Yeah.
I think we're going to wrap up the recorded section and then just stick around for more questions in a moment.